So, last class we have discussed about the first part, subsoil investigations, and why there is a requirement of your subsoil investigation, that means what is the need, and also we have discussed different programs, preliminary informations, reconnaissance survey as well as site investigation. I have finished up to preliminary informations and reconnaissance survey. Now, we are going to start with the subsoil explorations of your third part or detailed site investigations. Detailed site investigations, if I say it, then in this we can start with planning, making test boring or boreholes, then collection of disturbed and undisturbed soil samples, then laboratory tests, and in this case while collecting the boreholes also we can do if required field test. This is all about particularly detailed site investigations. We have to plan and decide how many number of boreholes to be carried out. Then once the decision has been made, then collection of disturbed and undisturbed soil samples at regular interval below the ground surface. Then based on the collection of the samples, we have to take a call what are the laboratory tests we are going to do. Then if required, some field tests also to be carried out. Now, if I come to part of this, what is the minimum of the depth of the boring? The question asked minimum depth of boring. What should be your minimum depth of the boring? Let us take an example. Suppose single footing is there, this is your column load. Suppose for example, this is my depth D and this will be a center line. Now, this I say delta sigma is your increase in stress because of your external loading, then variation of your overburden pressure or sigma B prime. So, first you find it out, net increase in stress, delta sigma under a foundation loading, then estimate variation of vertical stress, find variation of vertical stress sigma V prime, then determine, look at here, D is equal to D1, first one I say, at which your delta sigma increase in stress equal to 1/10 of your Q. Q is equal to net stress on the foundation, then D is equal to D2, at which, that implies at which delta sigma by sigma prime approximately 0.05. Then last one is your take D1 and D2 and take the smaller value. First one is your what should be in your subsoil investigation, what should be a minimum depth of boring, up to what below the ground surface, up to what depth you are going for your depth of the boring. If you look at here, if there is a ground surface, there are two ways. We will discuss latter part also. You can assume some value of your foundations initially based on the column load, and with this some value of the foundations and size of the foundations, then you have to take a call. Okay, if suppose this is say 2 meter by 2 meter or maybe rectangular footing. So, in that case, if this is the column load, for example say 1000 ton or 100 ton, then what should be my minimum depth of the boring, because it is a costly. If you go for a longer depth, definitely the cost factor will come into picture. So, first you find it out net increase in stress delta sigma under a foundation loading. How do you get it? Delta sigma here, this is a foundation loading, then it come back to your basic soil mechanics. Basic soil mechanics, what it will come back, that means if there is a kind of square footing or rectangular footing, then at the center at below certain depth Z, what is your increase in stress. Based on this methodology, find it out delta sigma. This is based on your Bosinick's equations. What is your increase in stress because of your foundation loading? How much is your increase in stress? You can find it out. Then find variation of vertical stress. Vertical stress is, this is gamma, either effective or total in terms of H. Find the variations. Then look at here. If this is my depth of the boring, if I say D is equal to D1, this D may be D1 at which delta sigma increase in stress equal to 1/10 of your Q. 1/10 of your Q. Q is your net stress on the foundations. That means net bearing capacity, you can say. Net stress on the foundation means bearing capacity or ultimate total stress minus weight of the foundation, that is your net stress. So, D is equal to D1 at which increase in stress which is equal to 1/10 of Q. Q is your net stress in foundation on the foundations. Then D is equal to D2 at which delta sigma by sigma 1, this is your sigma 1 or sigma B, you can write it, increase in stress under foundation loading, variation of your vertical stress, this ratio which is equal to 0.05. Then compare these two, D1 and D2, which is smaller? Either D1 is smaller or D2 is smaller. That depth you have to consider for your minimum depth of the boring. This should be your minimum depth of the boring. Once again, D is equal to D1 at which increase in stress under a foundation loading which is equal to 1/10 of the Q. Q is equal to net stress on the foundation. D is equal to D2 at which delta sigma by sigma B prime which is equal to 0.05. So, based on these two, compare these two, which is minimum, that depth should be taken as minimum depth of your boring. Now, part 1 is over, that is your minimum depth of the boring. What should be your minimum? How many number of the boreholes you are going to extract? How many? There are different codes, different suggestions also there. So, if I come to this is your depth of the boring, second part is how many. So, there is a thumb rule, it is not necessarily you are going to stick to that. For hospital and office buildings, hospital and office buildings, there dB is equal to 3s to the power 0.7 and dB is equal to 6s to the power 0.7. It is a, for this case it is narrow concrete building, and this part it is heavy and wide concrete buildings. So, what is the dB? Depth of boring in meters. Depth of boring in meters. Then S is number of stories. S is equal to number of stories. So, these are kind of a thumb rules, sometimes use these are kind of thumb rules, and generally the expenditure should be, you should not go for a depth of the boring, such a depth it should not be more than, means particularly your subsoil explorations should not be exceeding 0.1 to 0.5% of total cost, 5% of total cost of structure. So, be careful while choosing your depth of the boring. Earlier what I said, depth of the boring is your D1, D is equal to D1, D is equal to D2. Out of these two you take the minimum value. There are also thumb rules for hospital as well as office buildings. Depth of the boring dB is equal to 3s 0.7, 6s 0.7, and based on that you take a judgment, and these explorations, total cost of the explorations, that means boring, testing, it should not be more than 0.1 to 0.5% of total cost of structure. Now, if this is the depth of the boring, what should be the number of the boring? I said again and again. So, based on that, how many number of bore holes you can go for? I can say it, spacing of the bore holes. Spacing of bore holes, this is a thumb rule, this is thumb rule. Then I can say type of project, and here it is spacing. So, multi-story building, generally spacing in meter, we go by 10 to 30 meter, and one story industrial building, generally we go for 20 to 60 meter. Highways, it is a plane strain problem. Highways, generally we go by 250 to 700 meter. Then dams, 40 to 80 meter. This is a thumb rule, means based on your experience somebody can take a call. So, what type of projects it is? If it is a multi-story building, you can go for 10 to 30 meter, multi-story, 10 story or maybe more than that. So, 10 to 30 meter, if it is a kind of this area will be there, that means this spacing here borehole will be here, here will be here, 10 to 30, here will be here, here will be here, here will be here. Then if it is one story industrial building, 20 to 60 meter spacings, highways, generally highway is continuing, it is 250 to 700 meter, dams 40 to 80 meter. Despite that, these are all the thumb rules. Despite that, they have given a kind of, these are from the codal provisions, they have given a kind of rules. Despite that, suppose I am going to, or we are planning for a, there is a road here and there is a structure here, we are planning for this subsoil investigations as well as structural part. Then there is a kind of pond here, pond or maybe some kind of passage of water is there, low lying area. Even if you go for, suppose for example multi-story building has to be erected here, even if you go by 10 to 30 meter, despite that, because there is a pond here, you can take one more borehole here. So, this will come from your experience. It is not like that you can take it, as far as possible it should be a minimum. It should be a minimum, so that cost has to be within your limit 0.1 to 5%. Another certain part of your particularly depth as well as size as well as depth of the borehole as well as your what should be spacing. Generally what it says, I am drawing a figure, shallow foundations or maybe a footing. In a footing, what it says, if there are light structures, the boring should be extended at a depth equal to 4 times probable footing width. If it is B, generally we go by 2 to 4 times B, 2 to 4 times B. It is good if you go for 4 times B. Depth below the probable foundations, it should be 2 to 4 times of a B. Why it is 2 to 4 times of B? Because within this 4 times B, there is an influence of, this is called influence zone, ball shape influence zone, the soil mechanics part, particularly Bosinick's equations, you know it. So, generally the range is 2 to 4 times or generally it will be 4 times. So, that if you go it, because this is your pressure intensity, beyond 4 times there is no effect. If I go by borehole beyond 4 times, what will happen? It will be ineffective. If foundation is laying at a meter of say 1 meter depth below your ground surface, and suppose you say B is equal to 2 meter width of your foundation. So, if I go by 4 times, so that means you have to carry out up to 8 meter, 8 plus 9 meter, total 9 meter depth you will go by subsoil explorations. Beyond 8 meter below your foundation, what will happen? The pressure intensity or pressure ball will be effective. Beyond that there is no effective, means this footing has effective up to this depth, whatever is your load is coming, load transfer this depth. So, this is the rule, generally you can go it. And other part is there, try up to a level of, if you are getting a hard stratum, suppose for example in this case, even if it is say 4 times, in this case some cases there are layer soil, layer 1, layer 2, layer 3, layer 4, these are all soft soils. Try to do boring beyond soft soil at least one borehole. So that what will happen, you should know up to what depth your soft soils are there, and hard stratum beyond what depth it starts your hard stratum. So that you can get an idea, so that you can take a decision where you are going to put your foundations. Then these are all your tentative. What will happen once you finish your soft soil investigations? Once you finish your soft soil investigation, you are supposed to get soil properties every 1.5 meter or 2 meter interval. We will get back. This is called bore log data. Bore log data, you are supposed to get it. Soil profile every 2 meter. So, what will happen? Suppose I am getting 0, 2, 4, 6, 8, 10, 12, 14 meter. Then I can cross check. These are my tentatives. I can cross check where I can put my foundations. So, what will happen? Suppose water table is at here, then where shall I put my footings? So, then I can take a call, okay fine, up to 10 meter it is not soft, it will be kind of hard stratum. Then I can place in such a way that my footing will be lying somewhere else here, then the entire pressure valve covers your hard stratum. It should not go to your soft soil. So that bearing capacity or the capacity to take the load will be in safe region. So, this is one way around other. So, you go for a soft soil investigation with a tentative dimensions and take a call how many number of boreholes and what depth you are supposed to do. Once borehole has been made, you cross check whatever your column load is coming, whether with that column load or at what depth you are going to place your footing below the column. Then below this pressure valve should be within your safer zone or maybe slightly harder stratum. There are many things I'll discuss as we are going to progress. I'll discuss. Now come to this part. I am going to start it boring. So, there are different types, merits and as well as demerits also is there. So, first one is your trial pits. Second one is your wash boring, right. Third one is your auger boring. Then fourth one is your rotary drilling. How you are going to do the boring? What are the different methodology? So, how you are going to collect in the boreholes, how you are going to collect disturbed as well as undisturbed soil samples? First one is your trial pit. You can go for a trial pit, and on what conditions this trial pit you have to implement. Second one is your wash boring. What condition? What are the soil conditions? Third one is your auger boring. Fourth one is your rotary drilling. What you are supposed to get, this I am supposed to discuss in detail. What you are supposed to get from this? Suppose I am taking it by means of auger boring. First one is your depth and number of boring, you have taken a decision. Then once you have taken the decision of your depth and number of borings, then you go for auger boring. Suppose we have taken a decision in auger boring, what we are supposed to get it? We are supposed to get it soil samples. Soil samples. First one is your disturbed, and in this disturbed soil sample it is your remolded, and second one is your representative, and this one you are supposed to get undisturbed. Once you are doing a boring every 2 meter interval, you are supposed to collect disturbed soil samples as well as undisturbed soil samples. In disturbed soil sample, once you take it to the laboratory, some soils it will possible you can remold it to its original state, and other is a representative, and in representative soils particularly it will go for a classifications, and undisturbed soil samples generally used for your strength test like triaxial consolidations means strength test, you can use your undisturbed soil samples. Then there are different samples are there, samplings are there, that part also I will discuss. I will stop it here. So, maybe next class I will start off boring and what are the different methodologies, how this I will discuss in details trial pits, wash boring, auger boring, rotary drillings, and what are the different field tests we are supposed to do and why. This is what I am going to discuss. Thank you.